Blackout heat hack, stealing warmth from a frozen city. Your house is 38 degrees inside. The grid has been down for 5 days. Your neighbors stopped answering their doors yesterday. You have no firewood, no propane, no way to generate combustion heat without killing yourself with carbon monoxide in a sealed room. But outside that frozen window, there is heat. Not much, but it exists. Even at 10 degrees below zero, air molecules are still moving, still carrying thermal energy. The second law of thermodynamics says you cannot create energy, but you can absolutely steal it from somewhere colder and concentrate it somewhere warmer. This is not about starting fires. This is about understanding that refrigerators work in reverse. And if you understand the physics, you can turn your dead city into a heat source. Welcome to thermodynamic desperation. The science they don't teach you. Heat pumps are not magic. They are physics exploiting a simple truth. When you compress a gas, it heats up. When you decompress it, it cools down. A refrigerator moves heat from inside your box to outside your kitchen. An air conditioner moves heat from inside your house to outside. You are going to do the opposite. The compressor in every dead HVAC unit, every abandoned freezer, every car air conditioning system contains a treasure. Refrigerant coils, compressor pumps, expansion valves. These components can extract ambient heat from sub-zero air and concentrate it into a smaller space. The temperature differential is your weapon. Your body loses 2,000 calories of heat per day just sitting still in a cold room. That is 83 watts of continuous power hemorrhaging into the void. You need to recapture that. You need to steal heat from the air itself before your core temperature drops below 95 degrees and your brain stops making rational decisions. Hypothermia does not feel cold. It feels warm. That is when you die smiling.
Method 1. The salvaged compressor rig. What to do? Strip the compressor unit from any dead refrigerator or window AC unit. You need the compressor itself, the condenser coils, and the evaporator coils still connected. Find the low pressure side and the high pressure side. The low pressure side goes outside. The high pressure side stays inside with you. Run the compressor using a car battery, a portable power station, or any DC power source you can scavenge. Connect the evaporator coils outside where the air is coldest. Position the condenser coils inside your sealed warm room. As refrigerant cycles through the system, it absorbs trace heat from outside air and releases concentrated heat inside. Why it works? Even at -20 degrees Fahrenheit, air contains thermal energy. The refrigerant in the evaporator coils is colder than the outside air. Heat flows from hot to cold. The refrigerant absorbs that energy, gets compressed in the pump, and releases the heat on the high-pressure side inside your room. You are literally harvesting warmth from frozen air using phase change thermodynamics. A functional compressor rig can generate 3,000 to 6,000 BTUs per hour. That is enough to raise a small sealed room by 15 degrees. What happens if you fail? If you wire the system backwards, you will freeze yourself faster than doing nothing. If the compressor runs without refrigerant, it will seize and you lose your only heat source. If you puncture the refrigerant lines, you release toxic chemicals and accomplish nothing. If your power source dies, you have wasted critical energy reserves on a machine that is now dead weight. Test it first. Measure the temperature differential. Do not assume. Method 2. The passive absorption panel. What to do? Scavenge large sheets of black metal. Car hoods work, roofing tin works. Paint them matte black if you can. Mount these panels outside at an angle facing the weak winter sun. Even through cloud cover, solar radiation penetrates. Attach copper piping or aluminum ducting to the back of the panels in a serpentine pattern. Run water, antifreeze, or any liquid with a low freezing point through this piping. The black metal absorbs every photon of available solar radiation and converts it to heat. The liquid circulates through the panel, heats by a few degrees, and returns to your insulated core room. You have built a crude solar thermal collector. Insulate the return line aggressively. Every degree you lose in transport is wasted. Why it works? Black surfaces absorb 95% of incident solar radiation. Even diffuse winter sunlight delivers 50 to 100 watts per square meter. A 4x8 sheet of metal can harvest 400 watts on a clear day. That is enough thermal energy to keep a human alive if you stop the bleeding with insulation. This system requires no electricity, no moving parts, no compressor to fail. Physics does the work while you conserve your strength. What happens if you fail? If you use water and it freezes in the lines, the pipes burst and you lose the entire system. If your circulation stops, the panel overheats and warps, destroying its efficiency. If you do not insulate the return line, you are heating the outside air instead of your room. If the sun does not appear for 3 days, you have built an expensive sculpture that does nothing. You need a backup method, always.
Method 3. The ground loop heat sink. What to do? Dig below the frost line. In most climates, that is 4 to 6 feet deep. The ground temperature at that depth remains a stable 45 to 55 degrees year-round, regardless of surface conditions. Bury copper coils or PVC piping in a trench or vertical borehole. Circulate water or glycol through the buried loop. The liquid equilibrates to ground temperature. 50 degrees is not warm, but it is 40 degrees warmer than the outside air. Bring that liquid inside and run it through a heat exchanger. A car radiator works, a copper coil submerged in a water basin works. Use a small pump or hand crank siphon to keep circulation moving. Why it works? Geothermal energy is not about lava, it is about thermal mass. The Earth absorbs summer heat and releases it slowly through winter. 6 feet down, the temperature is stable because soil is an excellent insulator. You are tapping into the planet's stored heat reserve. A 30-foot ground loop can transfer 2,000 BTUs per hour into a small space. Combined with aggressive insulation, that keeps your core temperature above hypothermia range. What happens if you fail? If you do not dig deep enough, the ground freezes and your loop becomes useless. If your pump dies, circulation stops and the system equalizes to room temperature, providing zero benefit. If you use pure water, it freezes in the pipes and destroys everything. If you puncture the loop during installation, you flood your trench and lose your heat transfer medium. Digging is exhausting. It burns 1,200 calories per hour. Make sure the math works before you commit.
Method 4. The exhaled heat recapture mask. What to do? Your breath is 98 degrees. Every exhale dumps thermal energy into the room and it dissipates immediately. Build a simple heat exchanger mask using copper mesh, steel wool, or aluminum foil packed into a breathing chamber. Exhale through the mesh. The metal absorbs your breath heat. Inhale through the same mesh. The metal preheats the incoming freezing air before it enters your lungs. Wrap the entire assembly in cloth to prevent frostbite on your face. Seal it tightly so all breath passes through the heat exchange medium. Why it works? Your lungs must heat every breath to body temperature. In sub-zero air, that costs 20 to 30 calories per hour of continuous breathing. A heat exchanger recovers 60 to 70% of that energy. You are recycling your own warmth instead of donating it to the atmosphere. This also humidifies your inhaled air, preventing the lung damage that comes from breathing bone-dry frozen air for days. What happens if you fail? If the mesh is too dense, you suffocate from restricted airflow. If it is too loose, you get no heat exchange benefit. If moisture from your breath freezes inside the mesh, it blocks airflow entirely and you panic, rip it off your face. If you do not clean it regularly, bacterial growth in the warm, moist environment gives you pneumonia. Test it for 10 minutes before committing to extended use.
Method 5. The vapor compression still. What to do? Boil water using any available heat source. Capture the steam in a sealed container. Run the steam through metal coils submerged in the coldest available water or exposed to outside air. The steam condenses back into liquid water. As it condenses, it releases the latent heat of vaporization. That phase change energy can be captured and concentrated. Position the condensation coils inside your living space. The heat released during condensation warms the room. You have converted water into a heat transfer medium. Why it works? Water's latent heat of vaporization is 2,250 joules per gram. When steam condenses, it releases that energy as heat. 1 liter of water boiled and condensed releases 2.2 megajoules of thermal energy. That is enough to raise the temperature of a 10 by 10 room by 5 degrees. You are exploiting phase change thermodynamics. The same physics that makes sweat cool you down can be reversed to heat you up. What happens if you fail? If your boiling apparatus is inefficient, you waste more energy than you capture. If your condensation coils are not cold enough, steam escapes and you lose the heat to the atmosphere. If you do not seal the system, you are just humidifying the room, which makes cold feel colder through evaporative cooling. If you burn yourself during setup, infection sets in and you die slowly. Precision matters. Sloppy thermodynamics kills. Method 6. The human thermal battery. What to do? Fill large water containers and place them in the warmest part of your space during any brief period of heat availability. Water has a specific heat capacity of 4.18 joules per gram per degree Celsius. It absorbs massive amounts of thermal energy and releases it slowly. At night, when temperatures drop, position these water containers around your sleeping area. They radiate stored heat for hours. Your body stays warm without burning calories on shivering thermogenesis. Why it works? Water is the best thermal battery available to civilians. 50 gallons of water heated to 70 degrees and placed in a 50-degree room will release 100,000 BTUs as it cools to equilibrium. That is 8 hours of passive heating. You are time-shifting heat from whenever it is available to whenever you need it most. What happens if you fail? If the water freezes, it expands and ruptures the containers, flooding your space and destroying your insulation. If you do not insulate the containers, they cool too quickly and provide minimal benefit. If you position them incorrectly, the heat radiates away from you into empty space. If you have no heat source to charge the batteries initially, you are carrying dead weight. Thermal mass only works if you have thermal energy to store. Survival checklist. Locate and secure any compressor unit before others do. Test all systems at low power before full deployment. Insulate everything. Twice. Never rely on a single heat source. Monitor for carbon monoxide even without combustion. Ration your battery power. Heat is temporary. Death is permanent. Eat high-fat foods to fuel internal thermogenesis. Layer your warmth. Core room inside insulated room inside structure. Track your core body temperature daily. Prepare to abandon the system if it fails catastrophically. The city is frozen, but physics does not care about the blackout. Thermodynamics still works. Heat still flows. Energy still exists. You just have to be smart enough to take it.